Good evening, everyone, and welcome to our presentation about the development of integrated design. Now, this is perhaps a slight departure from the usual CIBSE ASHRAE seminar presentation topic, because it doesn't really deal with any particular technical topic, which I think would be more common for this group to deal with. But when we began to think about the kind of topics that we might be able to talk about and bring an interesting perspective to, we realized that one of the things that's quite unique about Foster & Partners and building services engineering and Foster & Partners is the way we work. And so really this is a presentation about the ways in which engineers, architects and other members of the design team collaborate within projects. And so hopefully there's something in here that everyone can take away and you'll all find it interesting and informative, but I guess you'll be the judges of that at the end of the day. Now I'll start with a statement of our philosophy, and our philosophy is that the best projects arise from a totally integrated approach to the design process, where the core disciplines work together to conceive and design a project from its earliest inception, which is a very kind of grand statement. But through the course of this presentation, we're going to explain what we mean by integrated design and why we believe in this philosophy, and also share some of our personal learnings from our experience of working at Foster & Partners about how to do integrated design more effectively. Now, again, another thing which is probably unusual about this presentation is that while I'm an engineer, Matthew here is an architect, so we thought it was important to give a balanced view of the design process. And so we'll start with some quick introductions of ourselves so you can understand our background and the perspective that we bring to this topic. So my name is Andrew Jackson. I'm a partner at Foster & Partners. But a little bit more about my background. I studied mechanical engineering at the University of Sheffield and graduated in 2005 and have worked in building design consultancy ever since. When I graduated, I knew basically nothing about buildings, if I'm being honest, and kind of fell into the building services industry, but very quickly developed a passion for design of buildings and working together collaboratively on projects. In my career, I initially worked at a company called Heywood, which was a sort of medium-sized engineering consultancy of about 800 people, largely based in the UK. We did a lot of public sector work. Subsequent to that, Heywood was acquired by Ramboll, who's a much bigger multinational consultancy. And in the course of my time at Heywood and then Ramboll, I worked in Chester, Manchester and London. And after the acquisition by Ramboll, a lot more in the private sector. And then subsequently moved to Foster & Partners in 2012. And whilst at Foster & Partners, I've worked on generally global, worldwide projects, largely in the private sector. So a lot of high-rise, commercial, retail, mixed-use infrastructure. So I've covered a lot of different types of working environments and a lot of different types of sectors and working practices. And so that's the perspective that I bring to this dialogue.
Brilliant. Thank you, Andrew. My name is Matthew Heywood. I'm Associate Partner at Foster & Partners. I'm an architect. I'm very honoured to have been asked by Andrew and peers to be a part of this presentation, sort of give the architect's perspective on the relationship between engineers and architects. A little bit of background from me. I haven't always worked in such a large practice as Foster & Partners. I studied architecture at Dundee University before starting work for Future Systems, which is Amanda Levite and Jan Kaplisky at that time, working on a range of exciting projects, but it included most notably the Lord's Media Centre at Lord's Cricket Ground, if you know that project, which is a very unusual project, and also the Selfridges Birmingham department store, but a range of other things. After leaving Future Systems, I was freelance for a number of years and then joined Foster, primarily working on Apple Store's project, which is a project that we're gonna sort of use as our example going forward. There we go, excellent, some nice pictures. So you can see bottom left there is the media centre at Lord's Cricket Ground, and this in the centre is the Apple Store in Champs-Élysées, which was opened at the end of last year. But we're going to talk about a range of other Apple Store projects that form good examples of what we're talking about. Thank you.
Now, I often hear building services engineers complain that architects don't really understand their needs. But I would argue that it's essential that engineers understand architects first, because they're traditionally the leader of the design process. Now, I'm not the first engineer to espouse the benefits of mutual understanding, as this quote from Ove Arup demonstrates, and I think we can agree that he's got a pretty good track record. So I think there's perhaps something in this idea of understanding each other better to improve collaboration. But how do we do this in practice? How do we go about understanding architects? Well, for the purposes of this presentation, I began with some representations of architects in cinema. The first and classic representation of architects in cinema is Gary Cooper in Fountainhead, which perhaps is a great reflection of the architecture profession as a whole. Then on to the classic The Lake, starring Keanu Reeves, is another great representation of how architects work and what they do. Another classic, Love Actually, Liam Neeson represents an architect in that one. And then my personal favourite, Woody Harrelson in Indecent Proposal. Now, it's not immediately apparent whether it's taught in architecture schools that you should do it in the bathroom with no top on, but that seems to be the route that Woody Harrelson's gone for in this one. So what did I learn from this? Well, one thing that kind of all these representations have got in common is that they portray architecture as a fairly solitary exercise, and it's often driven by quite a large ego, and that's how the portrayal of architecture is often seen in film. Now, I'd have to say that since I've arrived at Foster & Partners, I've found this to be almost entirely untrue, possibly with one or two exceptions. But I certainly learned that one of the big learnings from my time at Foster & Partners is that any scale of building project is really, the design of it is really a huge team effort. It's not one person sat in a room coming up with an idea and then going on to complete the design, although that seems to be how it's quite often portrayed in cinema. So I don't think there's a huge amount that we can learn from this, and certainly at Foster & Partners, I've very rarely seen architects topless in the bathroom sketching, no more than 5 occasions. So maybe we can't learn too much from cinema. One other thing that I'm very passionate about, in addition to engineering, is cycling. So I thought maybe there's something I can learn from cycling. Now, there's a very famous quote from Dave Brailsford, which is about the aggregation of marginal gains. And what he's talking about is that when you reach the pinnacle of performance, you need to make improvements in every aspect of what you do in order to make a difference. And I actually think that's very true about high-performance buildings of today. There's very few quick wins available for engineers. Most of the low-hanging fruit is gone. And so if you want to design a high-performance building that performs better than average, everyone in the team needs to do their bit, and everyone needs to be pulling in the same direction. So I think this is very applicable to the process of building design. Another quote, which I think does tell us something about designers and architects, is this one from Charles Eames. Now, I think engineers often can perceive that their input is seen as a negative influence by the architect. But again, that's something that I've found to be largely untrue. I think that architects actually, in my experience, enjoy working with constraints. And part of the reason for that is because it gives them a reason to do something which is a bit more heavyweight than just because it looks nice. And I think there's a real truth in there that good architects and good designers do actually relish constraints, but it's obviously important that they're presented in the right way. So, in conclusion, my learnings about architects and my time at Foster & Partners, building design is a team effort, and architects really appreciate good quality advice from all members of the design team that they get at the right time. Another thing that I would say is definitely true, and is a perception of mine that changed after joining Foster & Partners, is that the perception that design comes from a single sort of flash of inspiration that happens at some point and carries through into the final design. My observation of design at Foster & Partners is really that it comes from a lot of hard work, a lot of studying different options, a lot of iteration, and a lot of effort goes into it. It isn't something that just happens in a flash, which I think is a kind of misunderstanding of the way the design process works. One thing which is certainly true of architects, though, is that almost universally they've got a passion for design. I think as distinct from building services engineers, most architects made a conscious decision to get into architecture, and they followed that through from an early stage, through their career, through their education. to get to where they are, whereas I think the vast majority of building services engineers, myself included, kind of fell into it and perhaps grew to love it afterwards, hopefully. But I would say that it's important as an engineer to understand the value of beauty and the value of good design, because that really colours someone's perception of the building ultimately. And finally, the point that constraints can be a positive thing, but it is important to frame them in the right way, and also show some flexibility about the constraints that you impose on the design process at the right time. So these are my personal learnings from working with architects and within a largely architectural practice over the past 7 years.
I think Andrew's been quite kind to me. Maybe this is where it ends. So this image is what Andrew's hair used to look like before he shaved it all off. But no, I think if you follow through the analogy of what architects think engineers are, and take film as the guidance from that, I think it's actually quite an attractive idea, the idea of a sort of engineer as a sort of mad scientist, with unfettered enthusiasm for problem solving and working something out. I think where that sort of falls away a little bit is that we then kind of imagine that you guys could do anything, and if we just push you hard enough, then you can achieve something that is clearly impossible. I think then also you could say that the view of the mad scientist, you like, falls into two brackets, and that's either that engineers are sort of boring and safe in their approach to something, or that they're experimental and dangerous. And in reality, I'm sure you guys would accept that you want to be somewhere in the middle between those two things. You don't want to be perceived as being either of those two. But I think there is a danger from the architect's perception that it's one of those two things, and that we're either saying, come on guys, can you not try a little bit harder and make this a bit more interesting, or we're absolutely panicking that you've decided to do something that is going to get us into no end of trouble. So you know, maybe we've got something to work on there. And I think that comes down to a level of trust. And one of my first take-ups of what good integrated design is where you build up a relationship within the design team where you really trust the person, so that then when they say, no, you can't do that, or you can do that, but it's going to be within these constraints, that you can listen, you can learn, and you can understand. And I think that's where architects sometimes need to learn. I think the problem with that, though, is that then trust sort of implies a situation which is that, you know, basically when everything goes wrong, the engineer is there to save my life. And therefore I think that is a maybe a sort of more subservient, reliant role that I think demonstrates that we haven't quite got that right, and that we need to be both involved in not only how we implement a design idea, but we both need to be involved right at the beginning with forming the idea in the first place. And I think that's one of the things that I've learned at Foster's, the ability for engineers and architects to both be in the room when the idea is right at its initial birth is a much more positive way of designing than even leaving it for 2 or 3 weeks after you first get the commission, and then eventually getting the engineer involved and say, we've had this massively great idea, it's a really hot country, we're going to build this incredibly transparent glass box in the middle of this hot country. Is that okay, Andrew? And by that time it's too late. Some nods from the Foster's crowd. So I think that's the perception. And then the other thing is that we have this idea that you know, that you guys can do anything within the bounds of physics, and we're excited about that, but we do need you to tell us when something is impossible, like building a glass box in the middle of a hot country. I think this quote, design is not just what it looks like and what it feels like, design how it works, is a really good one. And I think we can learn a lot from other elements of design in architecture and engineering. And we can learn from how that's integrated together in a way that the beauty perhaps is the beauty on the inside as well as the beauty on the outside. I think that's a strong motivation for me, certainly. So what have we learned? What I learned, I suppose. Engineers enjoy a challenge, so actually, you know, the more complicated the task, that's not necessarily a bad thing. People get very excited about that. Teamwork is key, you know, valuing people and understanding how they work and how you work and how you can work best together. Create a place for innovation. So in our designs, I think we have to genuinely look for ways that we can push the boundaries of what we're doing in order to keep everybody excited about the project and moving forward. Because an engineer is not necessarily going to be excited about the same things on a project that I am. And I think that's important that everybody has something that they're sort of pushing forward with it. And then how we feel is much more than what we see. I think architects are very visual people. We deal in images a lot. But actually, you know, Andrew challenged me earlier this week to talk about how if you were blindfolded and you went into a building, what are the sort of feelings that you feel when you come into that building? You perceive a building in a completely different way if you're unsighted. And I think architects deal too much in just sight and not in the sort of feel and touch of projects. So this, I think, is quite interesting. This is a Winston Churchill quote. He said a lot of funny things, but this is an interesting one. We shape our buildings, thereafter they shape us. Now, I think this can be read on a lot of different levels. I think the first thing is we shape. He's not talking as an engineer. He's not talking as an architect. He's not even talking as a prime minister, I think, at this point. He's talking about the users of the building, the clients of the building, the architects of the building, the engineers of the building, everybody who's involved in that process. And I think that's a very inclusive team responsibility for something. It's interesting that when Andrew read this, he immediately suggested that this is a very positive thing and that we were talking about beautiful buildings that can inspire people. But actually, it can be read the completely other way around. You could say that this is talking about buildings that are designed by an egotistical architect who has no idea of what the client wants and what the user will experience within his building, creating buildings that are bad for people and shape them in a bad way, thick building syndrome leading to people being unhealthy, these sorts of issues. So I think it can be construed as being positive or negative, but I think it is also inspirational in terms of how we look to the future and try and create buildings that do really affect people's lives in a really positive way. So a little bit about Foster's, just to sort of place the conversation of our experience of how engineers and architects work together within Foster's. And forgive us, this is very much us talking about our experience. We understand entirely that we're fortunate, I suppose, to be working in this structure, but we also understand that there are lots of other ways of working. There are lots of other ways that architects and engineers work together. And I myself have experienced from my time at Future Systems, we were a small practice reliant on our friends at Arabs, effectively, to provide a lot of the support that within Foster's we take for granted. So I do understand that there are different ways and relationships that integration can occur. Unfortunately, we've got to tell you about what we know, and I think we'll tell you the good and bad about that. Foster's have obviously got a 50-year lifespan. We haven't been around for that length of time. But engineering was always at the centre of all of the architecture that Lord Foster started designing back in 1967 and has continued through what we design now today. It's only relatively recently that the integration of engineering into that structure has been so close. But I think you'll understand that that relationship with engineers outside Foster's for all of those years was a very similar strong relationship. I think it's important to say that we work on a very large scale of different projects, everything from very small elements of furniture and table decoration, if you like, to very large projects such as airports. And I think an engineering projects that are potentially very engineering-led, like bridges rather than buildings. And I think we like to try and involve the three core disciplines of Foster's: architecture, structural engineering, environmental engineering, in everything we do if we can. That doesn't always work, and there are only some projects where all three of us are working together and some projects where there are two of the core disciplines working together. Together with architecture, structural engineering, and environmental engineering, we actually have a range of other supporting things that departments within Foster's, which we're very grateful for, and we understand the privilege that that gives us. So we have a team working entirely on sustainability. We have industrial designers, urban designers. We have model makers. We have a materials research centre, and all of these things, I think, actually help the process of integration more. Because right from day one, you understand that you can run into somebody who has expertise in a very large range of different things. It's not just, there are a lot of architects in the world where you only meet architects. And I think that leads to a very blinkered existence, if you like, and Foster's is certainly not that. I'm going to hand over to Andrew to go more into the environmental engineering thing.
Thank you. Now, I joined Foster & Partners in 2012, as I mentioned earlier, as part of the environmental engineering group, which was formed in 2011. So it's a relatively recent part of the Foster & Partners story, as Matthew alluded to. And to give you a bit of more context of who's in our team, what it consists of, and what we do. Since 2011, the engineering team has grown to the point where it now comprises 72 people. Here's some of them stood outside in front of Albert Bridge. We cover a pretty wide range of disciplines. So we cover the traditional MEP disciplines, mechanical, electrical, and public health. We also cover environmental design and related sustainability topics, vertical transportation, and architectural lighting design as well. So it's really a mix of disciplines within a team. And within those disciplines, we've got a lot of specialist skills that we can bring to bear on really any kind of project. And since we've been here in 2011, we've covered a pretty wide range of projects in terms of scale and typology, ranging from smaller projects, including flagship retail stores, which we'll talk a little bit more about shortly. This one is Maggie's Cancer Care Centre in Manchester, which completed recently. So these are our smaller projects, but we've also done very large-scale, high-rise, mixed-use buildings, major infrastructure projects. So it's a huge range of stuff that we've covered in the time that we've been here. Now, most of the engineering team is based in Foster's London head office. Foster's has offices around the world, but the vast majority of the design work takes place in London. Now, that's quite distinct and different from most engineering consultancies, which, so if you have an international engineering consultancy, such as an Arup, an Atkins, an AECOM, a Borough Happold, these kinds of people, they will have offices around the world, and typically the local offices will take care of the project close to where those offices are. Foster & Partners is quite different in that regard, in that the vast majority of our design work takes place in London. And the reason for that is because of the way we work, which is in integrated co-located teams. So that's quite unusual, and it gives us a slightly different perspective than you might have from working in traditional engineering consultancy. As I mentioned earlier, I've also worked in that environment as well, so I'm kind of familiar with the different challenges and routes that that poses. So this is supposed to be an overview of the integrated design process followed at Foster & Partners, but obviously things are never quite as straightforward as they might be, and so we'll talk a little bit more about some of the differences and complexity that we encounter.
So it's always quite good to start with a bubble diagram. There are lots of different ways that people come to Foster's to employ them and come to other engineering firms and other architects to employ them. And we've tried to sort of analyse these in a few different ways. Perhaps this is quite a sort of traditional, maybe slightly old-fashioned route, which is a client comes to an architect and then an architect brings in a structural engineer, an MEP engineer to work on the project. It is a model that we're actively using at Foster's on certain projects, but I think it's not a particularly sound model for a number of different reasons. It might actually lead to better integration in that the architect is often very friendly and trusts the engineers that's appointed and has a great deal of say in who's appointed. And therefore they work with the same people repeatedly because they get on well, and they might say, well, hang on a minute, we're working on this project over there. Tom would be great for working on that project. We know him from a previous project, let's get him in and involved in that project. But I think what it misses out on is that it means that the engineers aren't directly relating to the client in any way. And the client is sort of waving up at the top there in a sort of hierarchy, not necessarily very integrated with the engineering process, not really integrated with the team. And I think if you start the project with this arrangement, you then have to work harder to make that work. So, you know, let's scrap that for a minute and look at one where you take a different approach and the client goes around and appoints the different people directly. That can work really well as well. The client is more involved in the process, they have more say about it. But maybe there's a slight problem in that the client appoints this engineer over here and this engineer over here and this architect over here, and these three parties don't necessarily work well together. I think, you know, there's always problems. And you'll see I have no perfect solution to this when we come to it. The other thing is to look at is how well do these three parties communicate. And I think there's a lot of new ideas about co-location and improving ways of communicating between the two. And these things can radically affect the way that the integration of the team works and are really important. Foster's for Apple stores, for example, are operating this sort of model effectively, where we're all together in one group, working together, and we're appointed directly by the client. That's quite unusual. Foster's are unusual in that respect. We're still a leading as an architect, but we have engineering involved. There are other companies that do that, but it's quite rare. Again, the client is slightly separated from that process. Then perhaps this is a maybe more typical view in that on the previous slides, the client's seen as a sort of individual, I suppose, appointing the whole team. Whereas increasingly clients are more complicated than that. And they have their own architects involved, they have their own facilities managers, engineers, even structural engineers on the client team, and then they're working with an architect in a structure like this. The problem with this is that then it creates the potential of a conflict and two things working against each other when they should be two things working together. So, you know, maybe that's not so good. Maybe we should start again with another diagram. Perhaps this one works a bit better, which is, again, moving the client to the center again and saying, you know, you're in complete control of it, but we're all going to be around you working from different views. The problem is that until this point, we've only had 4, and now in order to make my hexagon work, I've added a couple of extra people in there. But in reality, the world that we work in isn't just these people. We are often involved with local MEP engineers, local architect, heritage consultants, code consultants, local quantity surveyors, local project managers. The team is often much wider than that. And so maybe my diagrams aren't working at all, and we should scrap that idea entirely.
Yeah, so we discussed this quite a lot and kind of grappled over what the right answers were, what's the right way to do it, what's the wrong way to do it. And instead, we decided to go back to our own experience and see what we could draw from that. And because we're all sort of technical people, we're all engineers and designers, we thought it might be interesting to talk about some projects. So we're going to talk to you a little bit about projects that both Matthew and I have been personally involved in and have formed a big part of the integrated design story at Foster & Partners, which is the Apple Stores project that we've worked on. Now, Foster & Partners' relationship with Apple actually began with Apple Park, and this was open to employees recently in 2017. But Foster & Partners' involvement actually began in 2009, stemming from a phone call from Steve Jobs to Norman Foster asking for his help to design a new headquarters. And that initial contact subsequently led into Foster & Partners' ongoing involvement with Apple's flagship retail stores in a lot of places all around the world. And this timeline gives a quick overview of the completion of some of the Apple Store projects designed by Foster & Partners. Now, there's a few things that are interesting about this. One is that it's quite unusual as a designer to be given the opportunity to work on multiple projects for the same client. And so there's a real case of evolution in this process, not just in terms of the design that we did, but also in the way that we work together. So we got the opportunity to work again and again on similar projects with similar people and learn how to do things a little bit better. Another thing which is quite interesting is that although these projects were all initiated after Apple Park, they were all completed before it. And a lot of the design details which found their way into the final Apple Park design were actually developed through some of these projects. And so there's a real case of evolution of some of the details which began in some of these earlier projects and were improved and improved and improved to the point where they actually appeared in the final Apple headquarters. So it's quite an interesting opportunity to talk about how that design process can evolve. Now, people often ask about these projects. Why are they so complicated? Aren't they all the same? Essentially, it's the same thing in a different place, right? Well, that's not really the case. And there's a lot of different factors which play into these projects being very different. Now, from an engineer's perspective, one of the most important of those is climate. And this gives an overview of some of the climate zones in which we've completed these types of projects, ranging right from zone 0A up to zone 5A. So we've covered a huge range of climates within these projects. And again, while these projects do need to have a consistent aesthetic, because obviously it represents branding for Apple, there's a lot of other different factors which come into play as well. So culture is a very important thing to take into account. For instance, when we design these projects, we have different occupancy levels for stores in different parts of the world. In China, for instance, we'll design for an occupancy of 1 meter squared per person, whereas in Europe and the US it's a lot less than that. And so these kinds of things play into it as well. So although on the face of it, these projects do appear to be very similar and have a very similar brief and a very similar client, there's a lot of differences which make them extremely challenging. So we're going to talk about a few of these projects in a little bit more detail now to give you an overview of some of the technical challenges that we face.
Yes, so as Andrew said, we're talking about 3 specific projects, but we've selected 3 very different projects to talk about to try and give you an idea of the sort of broad scale of work that we do within the Apple Stores team and the differences in those things. You also see that there's sort of chronology to the project in that we start with a certain design in one way and then we end up with a design in another, and you can see some of the steps along the way. Apple Westlake was one of the very early ones that we completed in 2015. We kind of inherited a little bit of design from Apple when we started the project, in that they had a distinct way that they wanted to lay out their retail stores. They had a distinct idea of how they wanted to develop some of those things within it, and therefore this is what we would class the sort of stainless steel and glass stores of the past to a certain degree. But it involves some innovations that we brought to the table. One is the LTP, the ceiling, which is effectively a complicated element which provides light, but it's also got acoustic properties, and it orders all of the MEP in the ceiling. And Andrew will talk about that in a little bit more detail. This is it's got an interesting cantilever. The store, it's got a large area of glass. It's got a solar shading issues, which we've got blinds that deal with. It's a heavily populated store, which makes a big difference to the way that we would have to design it in comparison to other locations around the world. You can see the cantilever here now and the LTP. This is an image at night. At daytime, the LTPs are turned down so that it's got a sort of energy-saving mode there, so that they're lighter. This is a nice shot at night. And then with the blinds down in full sun during the day.
So a quick summary of some of the things that we had to deal with from an engineering perspective on the project. One is that the project is in ASHRAE Climate Zone 3A, which is very warm and humid, very different from the UK climate. There's a completely different code framework that we had to work with it. And humidity is also a very significant feature, along with some of the other environmental characteristics. There is quite high annual radiation compared to London and the UK, and so that drove us down some of the solutions that Matthew mentioned with regards to the blinds, etc. So that's just a quick summary of some of the climatic influences and the code influences. One of the big driving factors in the design of this project, and one of the big challenges that we had, was the kind of the aspiration of this big cantilevered floor plate, and also the column-free design of the space, which meant that it really was a kind of masterpiece of structural engineering. And this model kind of gives you some idea of the complexity of the structure that holds up this very simple-looking box that's actually extremely complex under the skin. And as most MET engineers know, coordination with structure is a big deal. And so when there's lots of structure to coordinate with, that gets inherently more complex. So this is what we were faced with from a structural perspective to deal with. The other point I would make is that the high amount of glazing meant that the loads could potentially be quite high at certain times of the year. And also that the high occupancy density also created a lot of internal loads and internal gains we had to deal with. So we were faced with a very dense structure, very high internal loads, very high conditioning that we had to deliver somewhere in the perimeter zone, but no real way of actually getting to it. So this was a big challenge for us. One part of the challenge is simply spatially, and so really there was no way that we could have got to the level of integration and complexity that we could have done without working so closely with the structural team and the architectural team. And the other aspect of it is within the performance. And so there was a lot of very detailed analysis that was needed in order to demonstrate that we could actually make the space comfortable. There was a lot of things working against us, from the height of the ceiling, which is a double, possibly even a triple height space in the main sales area, and also the fact that, as I mentioned earlier, most of the load is at the perimeter, but really it's difficult for us to get any air supply out there. And so this really was an exercise in kind of trying to deal with a lot of very difficult constraints. And if you take off the ceiling and look at what's going on in the ceiling void of this project, it really is like looking inside a watch. It's all very tightly coordinated, so that was one of the major challenges that we had to face within this project.
So moving on to Apple Regent Street. Apple Regent Street is a little bit closer to home, so you may have been there. But it's also not a new store in that we inherited its design from before. It was the first Apple store in Europe when it was originally opened. And we were tasked with reimagining what was inside, I suppose. And we had to sort of unpick what was there, build a new store, open it, and do all of that while maintaining a store throughout the whole of the construction process on site, which is quite tricky. and involves some very careful maneuvers of building staircases here, building a temporary store in the basement, knocking through into the basement, opening up this bit, moving over that bit, and probably I think was a real education in that being a really bad idea, and that we should never agree to do that ever again. But actually was fun to be a part of, and I think it did involve some fairly complex engineering elements as well, in that, you know, if you made any mistakes on site and the power failed to the store below, you know, Apple effectively had a sort of cost clock running of the money they were losing while you dealt with the issue. So that was just something we could never deal with. Unfortunately, that really, as far as I know, never happened. So we did have a brief period where there just wasn't a way of managing to close the temporary store on the Friday and open the main store on the Monday. So there was a little bit of a blank period, but it was very, very short. So this shows what the store looked like before, with the four big logos. Again, it was a sort of stainless steel and glass number. You know the location, I'm sure, for the people that are here, for the people worldwide. It's in the centre of London, in Regent Street. It's in a historic building behind a historic facade. The store looked very much like this before. It actually had more space when we started than it did when we finished, but I think we had more usable space as a result of the change. It was very badly laid out. It had a feature staircase right in the middle, which was, you know, lovely to look at depending on your point of view, but it didn't really work in circulation terms. This is a shot during construction, and that shows the sort of amount of steel removal that went into it to create some very slender columns to take out the mezzanine entirely in the space. Again, while all of this is occurring, there's a fully working store in the basement below at this point. And then this is the final store as it is. And really, it's an exercise in how to make something look very simple at the end, but have incredible complexity behind behind everything, behind all of the stone, you'll see that this is the sort of start of the departure of the design from the stainless steel and the glass. We've gone for more softer finishes. We've got some beautiful stone that brings a more warmth to it. We've got Apple's new sort of avenue design, which is intended to be a town square, if you like. So the avenues down the side are effectively the retail owners and stores and cafes around the town square. The trees and the areas are the area in the middle. And just below us here is the large video wall and the forum space, which is a little bit like the sort of, I don't know, the sort of central square where you might have bands playing or presentations or people might make speeches. And the idea that this was a sort of little community space and that people would move around was very much part of the narrative that went into all of the Apple stores from then on. So this was kind of the first one that we laid out in this manner. And then this is the store of the facade at the end. The logos have gone, much more transparency. You can see the trees on the inside.
Thank you. One slight departure, but I think it's an interesting fact anyway, so I'm just going to share it with you quickly. You might notice that there's 4 main arches within this building, and there's one smaller arch in the middle here. This building is actually owned by Crown Estates, which means essentially it belongs to the Queen. And this is actually the Queen's personal door. It's not actually a door at the moment, it's just a piece of glass. But the Queen has the right within the lease at any point to come to the building and demand to be allowed into the building via this entrance here, and have to be forced to remove the glass to let the Queen in. Not really related to the design process, but I just thought it was quite a nice little factoid. Okay, so the London climate, I'm not really going to talk about too much because we're probably all quite familiar with it's both good and bad. But I think after the experience of the Westlake store, as Matthew mentioned, at that point we really inherited a kind of a suite of design tools from Apple. And the challenge we faced there was really just fitting everything in and making it work from a technical point of view. With this project, we were really keen to kind of try and find some ways to develop innovations that would enable us to save energy, because that's really what we're interested in and what we're all about. So one thing we started with quite early on was climatic analysis, and psychrometric climatic analysis is something we do very early on in most projects here at Ostrom Partners. Now, while some of these lower temperatures here might equate to a fairly miserable grey day in London, what it does mean is that there's a lot of potential here for free cooling by pushing a lot of air through the building. Now, in very simple terms, with a typical overhead air supply system, you typically supply at 13 degrees C. And so that kind of limits how much free cooling you can get by just pushing more air through the building. If you revert to a more of a displacement type system, supplying air at low level and displacing the heat upwards, you'll typically supply at a higher temperature, 17, 18 degrees C. And that gives you a much bigger opportunity to achieve airside free cooling, or economizer cooling, as it's known in the US. There is a bit of a limit there in terms of moisture content, because you can't push outside air through the store if it's very humid. But generally, that's not a huge issue in London, because the humidity rarely gets above this kind of threshold here. So we learned from this analysis quite quickly that maybe displacement ventilation is something we should look at for this project. And that, coupled with the very high ceiling height of the store, was something we started to explore a little more. So we did some more analysis to determine the potential benefits of that, and identified that there was a saving to be made in the cooling demand. Now, most projects in London, people would think heating is going to be your main demand. In this project, because it's largely internal, it doesn't really have a great deal of interface with the outside, and the internal loads are so high from the occupants and the equipment that's in there, it's in cooling mode for the vast majority of the year. So that was really the big load that we were keen to try and address and reduce. And so we identified displacement ventilation as a means to do that. However, that's easier said than done in this kind of project. Now, Apple stores are known for their sort of high finishes and very clean detail. And so it's not simply a case of picking a displacement diffuser out of a catalogue and putting it in the building, as you might do if this were, say, an office development. So we began to look at the architectural aspiration and say, okay, whereabouts could we possibly integrate some displacement ventilation? And there's really a limited number of solid elements that we might use. There's the trees, but they're potentially going to be moved at a certain point in the future, so maybe that's not something that we could rely on. There's the tables themselves, but again, at this point, we thought they might be subject to being moved around at some point later on, so we didn't necessarily consider placing diffusers beneath the tables as an option. We thought columns, maybe we could use the columns in some way to supply air at low level, but again, this is not a feature that we have in every Apple store, and so maybe that's something we can't rely on either. And eventually, we settled on the avenue wall, which Matthew mentioned as a potential place where we could supply air into the store, and as a feature that would appear in all other Apple stores around the world. So maybe that's something that we could start to look at. So we did some initial CFD to look at the different options that we might achieve that by. Option A involves having a perforated fascia beneath the retail portion, and we had options B and C, which had high and low level shadow gaps and supply in different fashions. Naturally, from an engineering point of view, our favourite was option A because it appeared to work the best, but unfortunately the architectural...
Can I just ask you to pause for a second? We just lost the sound going out on the web.
Okay. Yeah, so as I mentioned, option A was the preferred choice from an engineering perspective, but option C was the preferred choice from an architectural perspective. Now, you don't need to be an expert in CFD to know that red is generally bad. So the initial study of this option wasn't particularly promising, so we knew we had a real challenge on our hands. But as Matthew said earlier, engineers love challenges, so we thought we'd get stuck into this one and see if we could make it work. So from here, we took on a lot more detailed analysis. The previous analysis was really a 2D analysis, and then we went into 3D analysis, and we looked at whether it would be possible to shave off aspects of the load by providing cooling in other ways through radiant floor and other means like this. And eventually got to a point where we felt it was possibly workable to condition the store primarily using air supply beneath these retail display cabinets. Which, if you go back to the original image, didn't really look as though it's something that would be possible. So, again, anyone who knows anything about CFD knows that it's not necessarily the truth, the whole truth, and nothing but the truth. So we also went into lab testing and used a much more technical measuring device, which is an engineer's hairy leg, to see whether we thought the actual sensation was acceptable. Again, there's very well-defined parameters for these kinds of things, and air movement which is acceptable largely in an office environment. But we were mindful that this is a retail environment. It's a lot more dynamic. People are going to be moving around, and so maybe we can accept a slightly more relaxed comfort brief. And so we really went on, as well as the data, we went on the feel of it. And this was actually instrumental in convincing the client that this was a workable solution, because there's a lot of initial skepticism on their behalf as well. So once we'd gone through the process of saying we felt we could make it work and it felt okay, then we went into the process of actually integrating it within the design. And the avenue wall itself is a very complex structure that's got a lot of subframe to it to hold it all up. Again, it's like an Apple store in microcosm. You've got a lot of complex elements that appear very simple from the outside. And this was a real exercise of working together with both the architectural team, the client team, the structural engineer, and the mechanical engineer to squeeze everything that we had to in there and make it all work and appear clean from the outside. And this was the eventual diagram that we came to. The other party to kind of mention is really the contractor. I think as designers, we can be a bit guilty at times of thinking that the project finishes when the design is complete, but really that's only when it's beginning. And so we have to take the contractor with us on this journey as well. And we did this by going to site, explaining the concept to them, and doing mock-ups on site and working through the process with them, and actually overseeing the construction and installation of this to achieve this final result, where the actual air supply is virtually invisible and almost entirely concealed. And you can see it from a couple of other angles here, but it really is a very discrete element. And so in this way, we were able to meet the architectural aspiration and also achieve something that made the project interesting for us as engineers, which was a more energy efficient system.
Actually, just before we we leave Regent Street, I think it's important to say that, going back to the topic that we're deciding to talk about today, one of the things that I would say with this particular element, okay, it's a small detail in a store, you know, it maybe doesn't seem terribly important. But one of the things that's interesting is I think that the client would not have allowed us to go so far down a route of experimentation and design in order to create something like this without the potential that actually they saw the potential that they would be effectively repeating this detail elsewhere in the world on other stores. They'd be developing it further. And that's proved to be the case. We've developed that into different versions as we go forward. But the only way that they can make that work is that they know that the same people will be involved in that next store and that next process, and they can take the iterative development of that design onto the next stage. And that's, again, where integrated design comes in, because they know that we can carry on the lessons learned from one project into another project and take it forward. I think also the other thing I would say about Regent Street is that for me it was a very special realization of how this can all work from an architect's perspective. There was a point in Regent Street where I could stand up from my desk and I could look around and I could find Andrew, I could find Tom, I could find Michael, I could find Wolfgang on the lighting, I could find all manner of different people who were working with different disciplines on the same project. And if we had a problem, we could immediately get to desks, grab a photocopy drawing from the photocopier, get a pen, get down to work and sort it out. And I've never worked in an environment before anywhere else in the world where you can do that so readily as the way that we had it set up for Apple stores and that we try and keep going as the Apple stores develop. Having said that, I know from the MEP team's perspective, that's not always the ideal way to work. Within a large organization like Foster's, to have the MEP team all scattered about amongst the architects working in individual teams can sometimes be a negative as well. And they found that they were losing some of the sort of collective benefit of being one group sitting together. So I suppose the thing that we've learned most out of that experience is that the flexibility that we have currently is probably the best thing. And that allows us the potential that when a project's on site or it's on a particularly tricky stage, we can bring people together, position them closely together, all working on one project. But when it benefits the wider team for them to separate it out, we can move as well. And I know that's a bit frustrating, possibly even more frustrating from the MEP team, who I think probably move about more than the architects do. Maybe we need to learn on that. But I think it's a really positive thing, and it's something that I found a great support in what we're doing. Moving on to Piazza Liberty. Piazza Liberty is again a very different store to Regent Street and to Westlake before, and this is the first of one of our sort of, I don't know, we call them flagships and global flagships, but this was a really sort of special project and a really complicated challenge. And by that time, Apple had fully engaged with us, not only in terms of how we then designed the store, but actually in the process of choosing a site and choosing a project. And Piazza Liberty in Milan is an interesting case in point. Originally it was a fairly underused, slightly dead square within Milan. Nice location, centrally, but not much happening, not much going on. Below the square was an old cinema, the redevelopment. And we came up with this notion of not building a store above ground, but building a store below ground. And you can see this is an image that Apple used, which kind of explains their process, if you like. So there's the original site here, then there's the 3D rendering of our aspirational image of what we wanted to achieve. There's a photograph of the construction, and then there's a photograph of the final store. And fortunately, the vision and the realization are relatively similar. Not always the case, I suspect, but it certainly was with this project. You can see that one of the ways that we were animating the space, but also harking back to the cinema design that was there before, was to create this sort of terrace seating area with the steps that people could come and sit, meet people on, or just be. And again, this is bringing light down into the store below, and it's creating that slightly sort of theatre-like space, I suppose. And then there's the main glass entrance, which is this sort of glass veil with water from the fountains on either side, which provides cool with the heat of the day in Milan. And you enter down between the fountains, effectively, down a beautiful staircase to the space below. And then this is the excitement and busyness of a store opening. If you've ever been to an Apple store on the day it opens, I wouldn't recommend it. It's very busy. There's a lot of very special people, I would say, coming to visit an Apple store on the day it opens. And I think we thought in Milan that the Milanese, the Italians, were going to be quite cool about it and not be as enthusiastic as, say, a store opening in Shanghai would be. But none of it. They appeared in their thousands and queued up for miles.
Thank you very much. So again, climate is different in Milan to either of the two previous projects. The Milan climate is a lot more continental than the London climate, generally hotter in summer, colder in winter. So that poses some challenges, a completely different code framework. Anyone who's worked on projects in Italy will, I'm sure, agree that it's fairly impenetrable, and I'm still, having been through this project and another project in Rome, I'm still not sure I fully understand it. So that was a challenge, but really the climate didn't play a huge part in this store because it was essentially below ground. So the environmental influence was fairly minor. This is the sectional diagram of the store. You can see the features that Matthew was talking about. We have the amphitheatre stepping down here and the main entrance here. So the actual retail space is all below ground. So as I mentioned, the environmental influence is somewhat mitigated by that, but there were a number of other engineering challenges that we had to overcome. One of them was about how we interface with the plaza and where we get fresh air from. That was something that was very difficult for us. Another thing that was difficult for us was heat rejection. So how do we deal with these things? There's no roof where we can put chillers, condensers. There's no obvious place to put louvers or air intake. So these were kind of very difficult concerns for us just from looking at the overall diagram. So the strategy that we developed looked something like this, where for the heat rejection piece, we actually relied on a water source heat pump, which was an open loop extraction and injection system into the local aquifer. So that was a really good measure on a number of points, in that it helps deal with the issue of how we deal with heat rejection, and it also helps improve the energy efficiency and performance of the store compared to a typical retail outlet. And I would say there's probably very few retail outlets in the world that are cooled by a water source heat pump. So that may even be a first. The other issue I mentioned with regards to connection to outside air and where we get fresh air from, we addressed that through connecting via the elevator up to plaza level, which sounds straightforward but actually became a very complex issue. And the other thing that we tried to do again was to employ a displacement ventilation system, because similar to the Regent Street project, we felt this offered some good opportunities for airside free cooling. A little bit more detail on each of those. This is what the lift shaft at the plaza level looks like. And this element at the rear of it is actually the main outside air intake, which serves the whole store. And it's very, unless you actually know it's there, it's very difficult to see it. So this is an element of integration in a very kind of physical and visual sense that we were able to detail something very nicely and very cleanly, which served a very positive functional purpose. As I mentioned earlier, we went down the route of a displacement ventilation system for this project, and we felt when we completed the Regent Street project that we really cracked that with the air supply via the avenue wall that you can see here on either side of the floor plate. The difference in this project is that the store is 50 feet wide, so there was no real possibility that we would be able to condition the entire floor plate just from the sidewalk. And so we realized we were going to have to introduce an additional point of air supply. And at this point, we looked towards the table as somewhere that we could supply air. And it was interesting that we learned more at this point that the table locations were actually fairly static within Apple retail environments. And so we felt comfortable in using that as a means of air supply. Again, though, the visual effect was very important, and it was important that they were virtually invisible. So we had to develop a custom user in order to do that, which involved a lot of the usual CFD analysis, lab testing to come up with a custom solution which achieved what we wanted to do from an engineering perspective, but also met with the architectural aspiration. So, what have we learned about following an integrated design process from all of this? I guess the conclusions I would come to about what are the benefits of integrated design. I think one is that it enables designers to make better decisions. I think the design process can be enriched through the availability of information at the right time to make the right decisions in the right way. So when an architectural team might be looking at different options, if they don't have the availability of engineering advice, they'll do that on an aesthetic basis and not necessarily on a technical basis. Now, at least if that information is available, they have an opportunity to consider the technical performance as one aspect of that decision. Not necessarily that it's always going to win the day, but at least it's on the table. So we get better decisions. For sure, working in an integrated way enables us to work faster and respond faster to change. And so that was something that was very important for these projects, which were on a very fast timeline, which is very typical of retail developments generally, because obviously any lost time is lost money. So speed is certainly something that an integrated process can offer. And kind of similar to that is the ability to iterate and look at lots of different options. I sometimes make the joke that this is option and partners rather than foster and partners. So that's really how the design process works. It isn't from a flash of inspiration. It really is about iteration and optioneering, and that gets us to the final solution that you see. And I think an integrated design process supports that well. The other thing it deals very well with is complexity. You saw on some of those projects some of the levels of complexity that we had to deal with in what was ostensibly a very simple project. But having that advice available on tap in the way that Matthew described really helps to deal with complex issues quickly and effectively. So that's what we've learned about the integrated design process of fostering partners, but obviously we're very mindful that there's lots of different ways of working, and those ways are all valid as well. So we kind of challenged ourselves to come up with how, as engineers, we can help to follow an integrated process more effectively. And here's some of the things that we came up with. Certainly one of the things that I've learned as an engineer here is that visual communication is extremely important. Architects think slightly differently from engineers and communicate in different ways. And I was certainly surprised at the first meeting at Foster & Partners I came to. I was expecting to sit down around a table, but instead found people stood in front of a wall with pieces of paper in front of them, had a pin-up. And that came as a shock to me as an engineer. But one of the things that I've learned is that architects and designers generally respond very well to visual communication. So I think that's something that all engineers can endeavour to do more of. I think having trust in each other and having good relationships is very important. Now, obviously, we have an opportunity to build that here through working on multiple projects together. So how do you do that when you're not working in that environment? Well, I think one is that you work on relationships with people. You try to avoid communicating via email. You communicate verbally as much as possible. Talk to people. Go and see the other members of the design team if you have the opportunity to, and communicate in that way. And that helps to build trust and relationships. And I think another important thing to do is to share lessons learned from previous projects. And I certainly recommend that at the beginning of any project, the design team gets together and talks about their lessons from previous similar projects. And then there's a lot of benefits from that. One of them is that you can incorporate that learning into the project, and also all the members of the design team begin to understand the value that all the other people in the team begin to bring to the process. So that helps in that regard. The point I was going to have here was co-location, but I changed it to a strategic co-location because, as Matthew made the point earlier, it can be something of a double-edged sword. And I think it isn't the answer just to put everyone in the same place and say, go and work together. It's really about having people together in the right place at the right time. But at other times, you might not want to have people together. They might benefit more from working within their own discipline teams, for instance. So it's definitely an important part of the process, but it should certainly be used with some care and thought about how and when to do it. But if there's really one message to take away from this presentation, it's really that early engagement is absolutely essential. Engineers have got to get in the game as soon as they possibly can. They shouldn't wait to be given a scheme by the architect. As soon as they're involved in a project, they should go over, see the architect, try and understand what they're trying to achieve before a pen's even put to paper. because as soon as a pen is put to paper and an idea is out there that doesn't have any engineering thought or input behind it, then potentially you're in the mode of trying to undo something that's already been done. So really it's about getting involved as early as possible, whenever the opportunity is. Don't wait till next week or the week after. As soon as you get the call or the opportunity, go and talk to the team. It's really important. So that's kind of what I would suggest as how we can all try and support a much more integrated design process. And so I'm just going to hand over to Matthew to finish off.
Yeah, just to wrap up. We thought you might like a quick sneak peek of something that's particularly relevant to us now this week, which is that the Fifth Avenue store in New York is about to reopen. And Deirdre O'Brien, the Senior Vice President for Retail and People in Apple, presented this as a keynote a few weeks ago. This is a store that was developed before we were involved in Apple stores again, so it's a little bit like Regent Street in that respect. And externally, it's about just sort of a refinement of the design from an external perspective. Internally, it's a completely different store, and it's considerably bigger than the store was before. It's very complicated for some of the same reasons that Regent Street was complicated in terms of its location. It's got this amazing feature, mirrored staircase that links up to the glass cube above. And we're really excited about it, and it opens on Friday. So thank you very much for listening. We'll see you soon.
Right, well, thank you very much, Andrew and Matthew. Now's your opportunity to ask questions. If you are going to ask a question, either speak up or move yourself towards the front of the room, because it needs to be picked up by this mic here. Whilst you're thinking of those questions, I'll just pitch in perhaps with the first question. This question is from Wim, and Wim is in Holland. And he asks, when did you start the conceptual design phase? At the beginning of, when was the beginning of a process? How early in the project were you involved?
From an engineering perspective?
Yeah.
Well, I think the answer to that question is immediately, even before you get asked to, because I guess one of the benefits of being here is that before you're even asked to be involved in a project, you begin to see things pinned up on the wall, and you kind of think, well, I haven't seen that before. That looks like a new project. And you go over and take a look, and you kind of get involved in that way. So it really is at the very earliest point where the story is nothing more than kind of a vision or an idea. And sometimes even before there's something down on paper, we'll begin to set out some of the constraints and the issues that we think the store is likely to face from an engineering perspective. But this is it's not something which is really particular to the process on these projects. It's something that's developed through these projects that we now use as an approach on all of the projects that we work on.
Okay, thank you. It's obviously an ethos that we hope all integrated design teams will follow to work early on in the process rather than bringing in the design engineer after everything's cut and dried, as we've seen historically.
Yeah, I think so. I think maybe that's borne out of the fact that if you go back 20 or 30 years, the role of the building services engineer is somewhat less than it is now, and it is really about heating or cooling a building that has been designed by an architect. I think that the sustainability agenda has really driven MEP and building services to the centre of the design debate, and in that way it can really drive the design. I think it's interesting that if you look at the modernist architecture movement, really the first aspect of that was that the structural aspects were expressed very clearly, and they drove the design in some way. But I think as we move forward in time, we start to see that the engine, the MEP, the building services aspects are beginning to be at least as important, and sometimes even more important on some projects than the structural aspects of the engineering, and they really can drive the design from the outset. So I think that's the reason for that.
Okay, thanks. Any questions in the room? Yeah, speak up or come to the front.
Yeah, it's really good to hear about the ventilation strategy on the Regent Street project. Because I was in there getting my phone fixed and I just couldn't fathom it. I was in there for ages waiting around. I mean, I look at some vents and stuff anyway, but I couldn't figure it out. There's no grills that I can see, no diffusers or anything. I'm interested in a few things. So how is the air exhausted? How are you extracting it from the space? Because I assume it's at high level, but when I was in there, I couldn't see anything on the ceiling anywhere.
Yes.
And then also, what sort of velocity are you supplying the air at low level? Because obviously that was a big part of doing all the testing. You didn't want to supply it too much velocity, but you have a lot of air into the space.
Yes. Absolutely. Yeah. And then, good question. And
I've got more. Sorry.
Okay.
And then, did you do any sort of post-occupancy evaluation at the end of the job to find out, were people getting like cold ankles, and was the air actually distributing up that mezzanine space? Was that getting stuffy at all?
Sure. Okay. Very good questions there. First of all, it's great that you can work out how the system works. That's kind of the idea. So very pleased to hear that. I think the first question was how the exhaust works. So it is a high-level exhaust because that's obviously how displacement works. You push the heat upwards and suck it out at the top. So it's a ceiling plenum return system. So the dark slots that you see in the ceiling have actually got a hidden reveal in them. So there's a 1-inch slot on either side of the main cover plate. So those openings are actually 6 inches wide. There's a 4-inch cover plate in the middle and a 1-inch opening on either side with a vision strip above it, so you can't actually see into the ceiling. Now that's all coloured matte black, so when you look at it from a distance, it looks like a continuous element, but there is actually an opening there for air to get back into the ceiling, and so it gets sucked out of the ceiling plenum. So that's part one. And that was all the way along. That trough. Obviously, one of the restrictions is all of the services are also in that trough. So you've got light fixtures, sprinklers, speakers, God knows what else in there. All the stuff that makes the store work sits in that trough as well. So it gets very congested. So there's a lot of work to do to make sure that actually works from a practical perspective. So that's how that works. In terms of the air supply, it's actually, you put me on the spot. I'm trying to remember the exact discharge velocity, but I think it's in the order of sort of 1 meter a second at the point it leaves the diffuser, which is very, very high for a displacement system. I guess we kind of took the view that, most of the comfort parameters that we work to are really developed for an office environment where someone's sat statically in the same place all the time. And obviously anyone who's sat beneath a drafty diffuser knows how unpleasant that is. Obviously in a retail environment like that, it's a lot more dynamic. People are moving around. They're not stuck in one place for any length of time. And so we thought we could go to a slightly higher velocity than would normally be considered acceptable according to standard CIBSE ASHRAE convention. So we developed a custom comfort brief that we thought was applicable to that environment and worked with that. And that enables us to have this higher velocity, and that enabled us to deliver the air volume that we needed, essentially. I think the other aspect to it is we kind of had two directions of jet coming out of that supply point. And also because it's angled downwards, which is again unusual, most displacement terminals point upwards, so it was angled downwards. It gave us an opportunity for, as the jet comes out, it induces air from the space, it gains mass, so conservation of momentum is it gets heavier, it slows down, essentially. So the jet slows down as it moves into the space, gets heavier and then pulls at floor level. So it does actually behave like a true displacement system, which you wouldn't necessarily expect with that kind of discharge velocity. That was question 2. And question 3 was post-occupancy, yes. Yeah, so that's a good point as well, because you do have different levels. And I would say it probably does get slightly hotter up there, but the way we deal with that is that there's air supply on the mezzanine level as well, and there's a slight oversupply to the return volume. So it tends to act as a pressurization to the double height space. So you don't really get air movement from the double height space to the mezzanine level. You're kind of pushing cool air in the other direction. So that's how you prevent warm air migrating from the double height space onto the mezzanine, if that answers the question. And then with regard to the post-occupancy, that is a really great question. Now, we were very keen to do this, but Apple weren't so keen on us going and asking their staff sort of how they perceived the store to be. But obviously, we thought it was something quite unusual that we're doing here, and we wanted to be sure that it worked quite well. And so we did have a few, let's say, covert missions to the store, because obviously the great thing about a retail environment is you can just walk right in the front door and take a poke around. So I've been back many times since the store opened, and kind of surreptitiously asked a few people, you find it comfortable in here? Is it okay?
They think I'm mad.
And generally they think, who is this weirdo asking me about comfort and not iPhone? But my kind of informal post-occupancy evaluation is that it generally hasn't even been perceived as an issue by most people. And most people don't even really perceive it to that. I think to the point you made about feeling it on the ankles, I mean, guys generally walking around in trousers, so they don't perceive it. I think maybe women who are wearing, let's say, a skirt or a dress and maybe their legs are exposed possibly perceive it a little bit more. But I think on balance, because you're there for such a short period of time and then potentially move away to another part of the store, it never gets to the point where it causes a real sensation of discomfort. So I think the informal feedback would be that it kind of works. It works pretty well.
It is interesting. Apple weren't keen on you asking their staff.
Well, I think
we've had that before as well, actually, with organisations.
Yes.
You want to submit a questionnaire to an office, but no, we don't want you talking to our staff about it.
Well, I think a lot of companies and Apple more than most understand the value of data. And this is essentially data and it's information. So that's one aspect of it. And they do conduct their own assessments to kind of establish these things. I mean, really what they're most interested in, they are interested in their staff welfare, but they're really interested in how it's perceived by the customers and how it affects sales. Because that's, these projects are beautiful pieces of architecture, but ultimately their reason to be there is to A, present a brand to the public, and B, to try and sell stuff as well. So they do a lot of analysis on how the environment affects sales and things like this. But obviously that's quite sensitive commercial information to them. So I think they're a little bit wary about having people intrude into that realm. So it's difficult but understandable, I think.
I think it's also, I mean, they're intensely critical of their own work, and that extends to being intensely critical of our work, and therefore they do a lot of lessons learned from projects, and then look at the next project. How can we do that better? We didn't do that particularly well in that project. We need to do that better. I think where we haven't managed to get is exactly what you described, which is sort of post-occupancy data and surveys of that. But they do. It's one of the wonderful things I think about the project is that we are constantly always talking about the next one, and at some point that will finish. But for the time being, it isn't, and it is about what went well there, what went badly, how can we implement that better? Even things like the locations of the tables. Can we then integrate something into the tables? It's all about sort of one step at a time and moving to the next one. And from my perspective, that's a really exciting part of it. But we do also understand that they're a massive organisation. They've got teams that handle the development, i.e. the building of a project, but then it effectively hands over to a group that run it for a retail store. And those two organisations haven't always communicated as well, so you don't find out some of the things that you might find out. And they're trying to work on that.
Yeah, I suppose they've got HR teams there, but it's interesting they wouldn't necessarily ask questions about how the building affects their productivity.
Exactly. Yeah. And one of the things that has improved greatly since we worked on Regent Street is the preservation team within Apple, who are the guys who are maintaining the store when it's handed over and making sure it works well, and the materials that we've made things from wear well and it can be cleaned easily and all those sort of things, are now feeding back much more in the earlier stages of the process to us and saying, look, you need to look at this, you need to look at that, because things like the back of house door that links the main retail space to the back of house is a door which is constantly swinging all of the time with staff coming in and out, and therefore it gets an incredible beating, and we have to work to make that better so that they have less problems as it goes forward.
Okay. Please. We have to wind up in a minute because we're well over time, but carry on.
Previous design of the Regent Street store, because that isn't that old, and why did it work?
Can you repeat the question?
The question was, from the previous designs of the Regent Street store, why did it need to be redesigned? I think it had been
10 years.
10 years, something like that. Yeah, I mean, for retail, 10 years is actually quite a long time for a retail store to not be refurbished in that time. And I have to say that when I went to look at it the week before we started to disassemble it still looked brand new. The preservation team that are involved in that process do maintain the standard of finishes that they started at the beginning of the project. I think from Apple's perspective, they'd already started to develop new design ideas. We'd already started to look at different stores. Regent Street is such an important store for them. They wanted that to be leading the way, I suppose, with the new design. So I think that was partly it. Maybe it has something to do with the fact that we're based in London. It's reasonably near to us. But they are constantly tweaking what they want to do, how they want to present the product. And, we've talked a lot about the architecture and engineering of it, but their vision for how they want to be able to talk to customers and to share ideas changes all of the time. And I think they were thinking they're just not providing the service that they need to provide at the store, and we need to do something about it. So,
yeah, I'd say that, and perhaps the other thing is, I mentioned that the point of the store is to sell stuff, but it's also the point at which Apple meets its customers, and so the appearance of the store is really kind of Apple's brand to some extent. They don't brand very heavily their outlets these days, more so in the past, but a lot of Apple stores these days have very little branding, and so the brand is really about how it looks. And if it starts to look kind of outdated and tired, it doesn't really induct their customers into the Apple world that they want them to make them feel a part of. So I think that's part of it as well.
Have you got a quick question? Speak up so we can.
Thank you, Lord Chair. How do you make the client feel confident for your integrated design? Because the integrated design are always not in common system. How can you make them feel confident?
So the question was, how can we make the design feel confident in an integrated design process? Well, I think part of that comes down to trust as well. And I mentioned the importance of building trust with the other members of the design team earlier. That extends to the client as well. I think as a client, Apple are unusually active and involved in the design process, far more than any other client that I've ever worked with before. And if you ask them, they would say that they design the store as well, and for sure it's a collaborative effort. So yeah, it's about building trust, about demonstrating to them that you know what you're talking about, that you've got prior experience, the quality of the work that you give them, that you give them comfort, that they're getting the information that they need. But it's a good question, and there isn't really a straightforward answer to that. And I'd say it's an ongoing process to kind of always make the client feel as though that you're the best team for the job. I don't think you ever get to a point where you say, right, we've done it. It's an ongoing thing.
I think the other thing is that actually it might depend on the project, because when we were appointed to work on Apple Park, we weren't appointed as integrated design, so we're doing only the architecture for Apple Park. They wanted to employ their own engineers and bring the team together themselves. For Apple stores, I think because of the complexity and the way that they wanted to work and the number of different stores that we'd be working on, they were really attracted by the facilities that the ability that Foster's is able to offer in terms of offering a one-stop shop for an integrated design team. And therefore, I think, if anything, maybe that integration was one of the major points of how we got the job in the first place. So we didn't need to do very much to convince them of that idea being a good idea, I would say. I think on other projects, and Andrew probably speaks to this better than I can, we do need to work much harder at sort of educating the clients, I suppose, of the benefits of us working together. Because from my perspective, it would be nice if the MEP team and the structural engineering team were working on a wider range of projects within Foster. It does vary depending on the project.
Yeah, it's a good point. I think a lot of the benefit of it is in the process, and the client doesn't necessarily always see the process. I think when you take a very like the Avenue wall diffuser is a very physical example of how things are physically integrated, and that's one aspect of it. But it's not just about things being cleverly fitted together spatially. It's about how we actually work together as a team, and you actually get a different outcome from that. Now, it's actually very difficult to demonstrate that. So yeah, that's something that is I'd say an ongoing challenge, and trying to convince clients that the benefit is you'll get a better end product. So yeah, that's something we struggle with and continue to work on, I guess.
On that, I think we're going to have to close. Great question to finish with, and it echoes a question that came in over web as well. We've been joined tonight by people in Hong Kong, China, Brazil, London, all around the world. So it's been a fantastic presentation by Andrew and Matthew. Thank you very much for an excellent presentation.